Okay, so I will solve this using node voltage method. I know these resistances are unreadable, so I will just state them. This is 0.5 ohms, 0.4 ohms, this one, 0.25 ohms, 1 ohms, 0.5 ohms again, 0.25 ohms, and this one is 0.2 ohms. So I will write the node voltage equation, the KCL equation at node 1, which is V1. So that will be V1 over all the resistances, so 0.5 plus all the resistances that are connected to it, so 0.25 plus 0.4, and then the other node, that is the adjacent node of this to this one, which is V2, and the connecting resistance is 0.4, so it will come as a negative V2 over 0.4. And this is the source. It is coming, the upper part is positive, the lower part is negative, so on the right hand side it will go as a positive, so 5 over the resistance, which is 0.5. so this one is becoming V1 1 over 2 is 2 plus 4 plus 2.5 minus 2.5 V2 is equal to 5 into 2, which is 10. So this equation is becoming 6, and then 8.5 V1 minus 2.5 V2 is equal to 10. That is the KCL equation for node 1. Similarly for node 2, it will be again V1 will come as negative and the resistance will be 0.4 plus V2 will have 0.4 plus 1 over 1 plus 0.5 1 over 0.5, and then negative V3 of 0.5, so 0. This is coming minus 2.5 V1 plus V2 will be, this is V2, 2.5 plus 1 plus 2 minus 2 V3, 0. So this is becoming minus 2.5 V1 plus 5.5 V2 minus 2 V3. So this is the second one's equation, KCL at node 2, and node 3 will be minus 1.5 V2 plus V3 over 0.5 plus 0.25 plus 0.2 equals to 0. So just going through it once. 0.5 because V3 0.5 here, this resistance, then the other resistance connected to ground, and then 0.2 is this one. So all the resistances that are connected to the node is coming as inverse, and the adjacent node and the resistance with which it is connected to the adjacent node is coming as a negative, and that node as well. So again the last one is this one, so 2V2 plus V3, here it will be 2 plus 4 plus 5, so 2 plus 4 plus 5, which I can write 12. Anyway, I will just one more line, so I will erase few part, maybe will erase this part. So this is the third equation, will be like that. So minus 2V2 plus 12V3 equals to 0. That's the third one. So these are the three KCL equations at three nodes. So what I can do is I can write them in determinant form to find each of the node voltages. So here are the equations, three simultaneous equations, and the right hand side for the first one is actually 10, 5 over 0.5, and this one. So if I write in determinant form, the V1, unknown V1, which is the first term in the determinant form, the denominator is all the coefficients, so V1 8.5 here, so it's like V1 v2 and 0, v1 and v1 is 0 for the third term. For the second term v2 and v2 is this one, so this, and v3 first one is 0 and the second one is -2 and 11. And the numerator, since this is the first term, the right hand side comes and replaces the first row as before. Is exactly same as loop current method. It's just solving 3 simultaneous equations using determinant method. And then here I have written them down. So for 8.5 it's coming this cross this multiplied with this cross this, so 5.5 into this one, minus of -2 into -2. For this one it's coming this one times this one minus 2 0, so 2.5 times 11 minus 2 into 0, and for the last one it's a 0 anyway, but this one with this one and this one with this one, so 2.5 into 2. And similarly the numerator will be like that. And v2, for v2 the second row will be replaced by the right hand side and first row will remain as like that. For v2 the second row of the numerator will be replaced by the right hand side and the denominator will be remain the same, of course, and the first row will be as same as the denominator, and so as like for the third variable v3. So yeah, I took a snapshot to show a correction here. This one should be a negative and then the negative should be here, just like on the numerator.